at the section 4 in chapter 4, and we're going to talk about applications dealing with common logs. So one application is in chemistry, the pH level of a solution can be defined with this equation, negative log of H3O positively charged, and so that is hydronium ion concentrate. And so based on how much solution we have, we can find the pH level of a solution based on this equation. So if we look at with a pH solution that has an ion charge of 2.5 times 10 to the negative fourth. So we're looking at this solution, don't know what the solution is, but it just has an ion level of 2.5 times 10 to the negative fourth, and I do believe those are in moles per liter. So we're going to find out, okay, what is the pH level of this solution with 2.5 times 10 to the negative fourth moles per liter of ion or hydrogen ion concentrate. Okay, so we're going to use this formula for pH, and we're going to use our properties of logs. We have a log in it, that's the whole point, right? It's a common log, base 10. It's just log. And so here's our ion concentrate, 2.5 times 10 to the negative fourth, and so that's going to go in for my hydronium ion there. So let's find out what this pH is. So negative log of 2.5 times 10 to the negative fourth. And now I'm going to use my properties of logarithm. Say when I'm multiplying, if I have a product, if I'm taking the log of a product, I can separate that into two logs. And that is the log of the first term plus the log of the second term. Okay. And so this negative's on the outside here. And then I can use my power properties. Let's say if I'm taking the log of a number that's being raised to a power, I can move that power in front of the log and multiply that by the log. Okay. This is for the next problem. I'll erase that. Okay. And then now we can go ahead. You can distribute that negative, or you can simplify this. Doesn't matter. So we can put these in our calculator, and we get 0.3979, and then 10 has base 10, right? Log has base 10 raised to 10, so this is going to equal 1. So I just get negative 4 here. Now I can distribute that negative. So I get negative 0.3979 plus 4. And so then we get our pH level is equal to, or approximately, 3.6. Okay, so that's what our pH level of whatever this solution is when it has a hydronium ion concentrate of 2.5 times 10 to the negative fourth. Now, what if we want to find how much hydronium ion concentrate if we have a pH level of 7.1? What is the concentrate of the hydronium ion? So here we know our pH is 7.1, and we're trying to find this hydronium ion concentrate. Okay, how much of that we have in our solution. Okay, so 7.1 is equal to this. Okay, and now we can go ahead and multiply both sides by negative, so negative 7.1 to get rid of that negative log. Okay, now I solve logarithms by switching it to an exponential, right? because that's what all logs are asking. This is asking my base, right, is 10. 10 raised to negative 7.1 is the hydronium ion concentrate. Whew, it's hard to say. Okay, so and then I can go ahead and do this on my calculator, and I get that the concentrate level is approximately 7.9 times 10 to the negative 8. Okay, so there's a problem for you, and there's a few more examples that I'll do, and then we'll work on some homework problems. Okay, so we'll use this formula again, and now how about try this one. Try what if the hydronium ion concentrate is 6.3 times 10 to the negative 5th. What would be the pH level? So go ahead and pause the video, try this out, and then come back if you need any help. So I can plug this in, 6.3 times 10 to the negative 5th. I can use my properties of logarithms to separate it. The log of the first term plus the log of the second term. Now I can move that exponent out front. Now I can go ahead and log 10 is 1, so I get log of 6.3 minus 5, and then log of 6.3 plus 5. I can distribute that negative as well. So a negative log of 6.3 plus 5 is approximately, the pH will be approximately 4.2. And so now we can figure out, is that acidic, is that alkaline, based on our pH scale, and see where it falls in there. Okay, so here's some examples of measuring the loudness of sound. We have our decibels, and we have our intensity, and we're going to figure out the decimal rating. So we have our decimal rating. D is equal to 10 times the log of the quotient I over I sub 0, where I is intensity. So I is an intensity, and then the I sub 0 is just kind of our initial intensity, kind of the thresh, like the beginning of our sound, called the threshold sound. Sound. Okay, so we're going to give, if we want to find the decimal rating, if our sound intensity, so if the intensity of our sound is 10,000 I sub 0. So we want to find, so we're going to replace I with our 10,000 I sub 0. And so our decimal rating, which is in decimals, is equal to 10 times the log of our intensity over our threshold sound. So our intensity over our threshold of sound, which we don't necessarily need to know because these will cancel each other out. And then I'll just have 10 times the log of 10,000, which you could put this in your calculator, but remember my base on just log is 10, so 10 raised to what is 10,000? Well, that's just four zeros, right? So that equals 4, and then 4 times 10 is 40. So then I have a decimal rating of 40. So then here are some homework problems that you can work on, 29, 33, 37, and 63, and we'll go ahead and do those now. Okay, so number 33 is saying that the soda pop is 2.7, has a pH level of 2.7. We want to find the hydronium ion concentrate. So here we're using this pH formula. So we can enter that in as our pH 2.7. So this is kind of like the second example of that one. And then we can multiply both sides by negative to get that log by itself. Now we can go and switch this to an exponential, right? Because that's what solving a log is. 10 raised to negative 2.7 is equal to the hydronium ion concentrate. Okay, and then you can do that on your calculator, and we get 2.0 times 10 to the negative 3. Okay, so there's our answer for number 33. Okay, so here is grapefruit. We actually want to find the pH level of grapefruit if we were giving a ion concentrate, a hydronium ion concentrate of 6.3 times 10 to the negative 4th. So this is the first part. So we have our hydronium ion concentrate, so we plug that in, use our properties of logarithms, log of 6.3 plus log of 10 raised to the negative 4th. Now we can go ahead and remember this pH. So this is, I'll just go ahead and distribute that negative. So once you do these you can do most of these all in one fell swoop. So it becomes a positive 4 because we're using the power property, and log of 10 equals 1. So I get negative log of 6.3 plus 4, and that's going to be approximately 3.2. So our pH level, approximately 3.2. Okay, so here's another one. Here is your hydronium ion concentrate. And what you want to do here is you want to find the pH level, and then you want to see, okay, is this pH level, because it's kind of relating, I guess, to the wetland area, and seeing if it's too rich for different animal species that are in the wetlands, the fins. You're going to determine what the fins are, if they're rich, or determine what the wetlands are, if they're rich fin or a poor fin or a bog. And so you're going to have to go back to example number 3 in your book and kind of look what that relates to once you find your pH level. So remember, our pH level is equal to negative log of our hydronium ion concentrate .49 times 10 to the negative 5th. We can use, let's just go ahead and do them all at once, right? So I'm going to distribute the log. Oops, 49. And then it's going to become a positive because I'm going to bring the negative 5 down, but I'm distributing that negative, so now it's going to be positive. And the log of 10 is 1. So there we go. That's what it looks like. So our pH level is approximately negative log of 2.49 plus 5, which is, and so make sure you put it in your calculator. You can do negative log, automatic, that pops up. Close that, then press 5, right? To make sure, then you get about approximately 4.6. And so then we check the wetlands back in example number 3. We're going to check that and see, okay, if it is between 3 and 6, it is a poor fin. So So yeah, so ours is 4.6, so it's between 3 and 6. It's a poor fin. If it is a rich fin, then it's between 6 and 7.5, and if it's a bog, then it's less than 3. So ours is right in the middle, so it is a poor fin. So it's a poor fin. Poor fin. So there you go. So number 63, you're looking at finding the decimal ratings for several different things. So here you're given intensity of 100 I sub 0, and then 1,000 I sub 0, and so on. And then you want to find out, okay, if the intensity of the sound is doubled, how much is the decimal rating increased? Okay, so how much if the intensity is doubled. Okay, so that means if I here is at 100 I sub 0, it'd be at 200 I sub 0, right? That would be double intensity. How much is my decimal rating D for this one and D for this one? How much is that increased? If it's 1,000, what's my decimal rating? And then double would be 2,000. What's the difference in my decimal rating, right? How much does it need to be increased? And we can figure that out. Okay, so here is my decimal rating, 10 times the log of I over I sub 0. And so here are my intensity levels. Here are my I's. And we'll do the other ones as well. But we can kind of see what happens as the number increases, because it's all base 10, right? The common log is base 10. These are all have zeros on them, so they're all base 10. And so we can go ahead and plug those in. And just be careful when you write 10 and you write log, like this log right here, this L and O kind of looks like a 10, so don't try to not be confused about that. So I'm going to enter in 100 I sub 0. So my I sub 0's are going to cancel out, right? And then I'm going to take the log of 100, which is just, 10 raised to what is 100? How many zeros do I have here? I have 2 zeros, and then 2 times 10 is 20. Okay, so that'd be A. B is then taking 1,000. All right, so basically 1,000, log of 1,000. How many zeros do you have? That'd be 3, and then times 10 would be 30. C is 100,000. So basically, how many zeros do you have? You have 5, and then times 10 would be 50. And then D is 1,000,000. How many zeros do you have? You have 6. 6 times 10 is 60. So those are all my decimal readings: 20, 30, 50, and 60. Now, it's asking how much would it take to double, right? So, like this first one, we plugged in 100, right? So what if we plug in 200? I sub 0, I sub 0, those are going to cancel. We take the log of 200, and then we're going to times that by 10. So if I take the log of 200, this one's a little bit harder because I'm 10 raised to what is 200, right? And then I have to times that answer by this 10 right here. So I'm going to have to do that on my calculator. I'm going to hit log, then I'm going to hit parenthesis, automatic comes up. I'm going to hit 200, close off that, hit enter, and I get 2.3, and then I'm going to times that by 10. So I'm just going to move the decimal over to 23, right? So to double, I would need 23. Okay, so how much more is that? So if the intensity doubles, how much more is my decimal rating going to increase? What about if I plugged in 2,000? So log of 2,000. I'm just adding another 0, right? Just doubling this 1,000. So I get 3.3, and then I times it by 10, so I get 33. Well, how much did it increase? It looks like it's the same. It's increasing by 3. So E is about 3 is the increase, right, in decimal rating when the intensity doubles. Okay, so those are all your problems for this part, the application of the common log.